I'm Ben Schmidt, your kinematics expert.
And I'm Braden Bench, your Newtonian expert.
And today, we'll show you how basketball applies to science.
Now off to our kinematics expert, Ben Schmidt.
Oh, hello there. I'm Ben Schmidt, your kinematics expert. Speed is the rate of change in a position. An example of speed in basketball is the time that the ball leaves my hands to the time that it enters a hoop. It took 1.07 seconds for the ball to leave my hand till it made the hoop. Splash. Velocity is the change of speed and direction in an object. An example of velocity is when a basketball player doesn't move. You might ask yourself, how does speed and velocity differ? Let's see here. Velocity has to do with the direction of the object. Acceleration is the rate of change of velocity. To calculate average speed, you take total distance divided by total time. Okay, so the court is 21.34 meters. So if I type that in, 21.34 divided by how long it took me, which was 4.16 seconds, I get 5.12980769. But in sig figs, 5.13. Gotcha, Mrs. Larson. Friction is the force that opposes motion between two objects. Example of friction in basketball is the shoes you wear on the court and how they grip. Now for our Newtonian expert, Braden Benz. Nice shot, Braden.
Sir Isaac Newton said, an object in motion tends to stay in motion, while an object at rest tends to stay at rest. An example of this is that the ball won't stop until it hits something. Or when a shot is blocked.
Ah! Not today, son.
A net force acting on an object causes it to accelerate in the direction of the force and needs more force if there's more mass. This is Newton's second law. How do force and mass affect acceleration, you might ask yourself? Well, if there's more mass, you'll need more force. If you don't use more force, there will be less acceleration. Ben is dribbling a ball with a very light mass. Therefore, it'll take less force for it to accelerate when I steal it away. Ben is dribbling a ball with a heavier mass. Therefore, it's going to take a lot more force to cause it to accelerate with the same amount of force that the lighter ball took when I steal it away. For Newton's third law, he says, for every action there's an opposite and equal reaction. An example of this is when Ben blocks Cole's shot, ball hits hand, hand hits ball.
In this video, we learned that speed is the rate of change in motion. Velocity is speed and direction of an object, and acceleration is rate of change in velocity. In this video, we also learned that friction is the force between two objects that opposes motion, and that how How to find average speed is you take total time divided by total distance. Oh!
We also learned about Newton's laws and how they apply to basketball. For example, an object in motion will stay in motion until an unbalanced force acts upon it, which is his first law. Newton's second law is a net force acting on an object causes it to accelerate in the direction of the force. His third law is for every action, there's an opposite and equal reaction. Now off to our kinematics expert, Ben Schmidt. Oh my, oh my!
Velocity differ. Let's see here. Velocity has to do with the speed, the direction of the object. Gosh. Oh! Oh my gosh, it slipped. Okay, so. Now to our Newtonian expert, Braden Benz.
My bad.
Now to our Newtonians expert, Braden Benz.
Oh.
Darn.
Ben is dribbling a ball with a light mass.
Oh,
Therefore,
gosh. It gets stuck in the grooves.
therefore,
In this video, we learned that speed is the rate of change in motion. Velocity and acceleration. Oh crap, I just didn't even. Oh! We also learned that friction is the force that opposes between two.